In the last lecture, we configured our simple Metasploit-based C2 server and then had the operator call back to it via a reverse TCP interpreter payload that was spawned by exploiting a Windows system. Now we have administrator access to that system and want to do some post-exploitation. So this lesson isn't going to deep dive into any advanced techniques for post-exploitation. We're just going to use what Metasploit provides out of the box, which is honestly really good for what it is. It just depends on the TTPs that you're trying to emulate as a red team. In our case, we're emulating the TTPs an attacker could use if they only made use of Metasploit. Now, obviously in our fake environment, we're set up to succeed, but keep in mind, because Metasploit is a known tool, it often is difficult to use interpreter payloads out of the box on real engagements. To use them, they'll often require some modifications for evading defensive protections. That said, it's still a fantastic tool, and it has applications even in advanced red teaming scenarios. As the red team, the TTPs you're trying to emulate drive your engagement. This includes the tooling you may use for the operation. So with that, we're sticking to Metasploit. But we need to follow the next step in a typical red team process. I'm going to call back to the Red Team Development and Operations book by Joe Vest and James Tuberville for this. In Red Team Development and Operations, 3 execution phases are described. Phase 1 is to get in. This means actually gaining access to a target's environment, systems, buildings, or whatever the goal may be. We conducted Phase 1 in the previous lecture. We are now in Phase 2, stay in. Stay in is synonymous with a common term that we hear in penetration testing lifecycles known as persistence. In the red teaming context, this can be maintaining access to a physical location, an asset, or like in this scenario, a computer system. Our goal is to ground ourselves in this system to ensure that we don't lose access, and if we do, that we can quickly get it back. We need to do this before we move on to Phase 3. Phase 3 is to act, or take actions on the objective. If our next goal is to move laterally on this network, or even just steal documents on the system, we don't want to do that just yet. It may be tempting to, but if we start acting now, and we're caught, or we lose our shell for any reason, we're going to quickly regret acting. So we need to establish our presence, cement ourselves, and then have a look around to see what is reasonable for us to do. Even before we execute some of our persistence, we need to examine the system as quietly as we can to make sure that we don't execute something that is going to compromise our stealth. Now, in this scenario, we are pretty safe. I'm going to take a quick peek at some running tasks, and in this current phase, our operator is still ready to re-exploit the system to regain our access if need be. So we haven't really called them off just yet, because we're following the classic rule of 1 is none and 2 is 1. So since we only have 1 shell, they know not to clear out until I tell them we're established or they absolutely have to. That puts the onus on me to work quickly and efficiently to establish our persistence though. So, like I mentioned, I'm going to do a quick process check. And just kind of looking at the system, looking at the processes that are running, it looks like it's a pretty bare bones out of the box Windows systems. It looks like somebody set this up and kind of left it dormant. It's just kind of been hanging, no updates, nothing. There's nothing really fancy that I see here based on the process list alone. So the first thing I'm going to want to do in this scenario is drop another payload onto the system so I can get more shells back without doing exploits. Now since I have system access, I can simply upload another interpreter binary. But before I do that, I want to check and see if we have AV enabled. So far, based on the process list and based on all the actions we've taken, there doesn't seem to be any endpoint protection enabled. You see, nothing stopped our exploit, and we do currently have an interpreter process in memory. During planning against this target, we knew that they had weak endpoint protection, so we aren't worried about being too noisy here. That said, I have known Windows Defender just to arbitrarily turn itself back on, either via Windows Update or something like that. And Windows Defender does have definitions for interpreter. So we just want to take a little bit of extra caution before we start throwing payloads around. That said, obviously this system hasn't been patched in a while, and any configurations it has are probably the same when it comes to firewall and AV. So this isn't looking too good for them. I'm going to drop into a shell and run a quick sc query windefend. Looks like Windows Defender is running, so we're actually going to want to disable that. So we'll say sc stop windefend, and then run another sc query windefend, and it looks like Windows Defender's process has now been stopped. Awesome. So now we shouldn't have to worry about AV catching our payloads or doing anything funky like that. Now, one thing to keep in mind is normally I'd want to script out all of this. If this was a real engagement and not a lecture, I have now left my operator hanging for way too long. My payload should be pre-staged, my post-exploitation techniques should be scripted based on the research and testing that we did beforehand. This course is not covering red teaming as a whole though, just the back-end operations for what it takes to actually set up infrastructure and run an operation on that side. So we're assuming a lot of steps have already taken place here for the sake of getting our hands dirty with the practical skills needed to operate the back end of operations like this, which means, in our case, doing things manually that we would automate just to see how they're broken down. So just keep that in mind. This is a lecture, but in the real world, these steps need to be prepped, tested, and ready. Okay, so we're going to use the payloads module to generate the same payload we've been using. And we're going to name it something like cmd.exe just to be a little inconspicuous and hide it in a directory with some other system executables. Maybe somewhere around system32 or sysfile64. Not in those directories because we'll have to do some weird things to overwrite actual command prompts and we don't necessarily want to do that. But just in that general location, so it seems pretty normal looking. Seems like it's supposed to be there. It'll be relatively difficult to spot, and most people will probably overlook it. I know I would, unless I was just actually really trying to find the differences or paying attention to timestamps and file modifications. So just to the naked eye, it'll be pretty inconspicuous. So we'll exit out of our shell here and background our session, and then use the payload module. So we'll use Windows payload, x64, interpreter, versus TCP, just like before. We're going to set our L-host to be the udemy-c2.injection.sh and the L port to be port 80 as it has been. And we'll say generate in the format which is -f of exe, and -o we'll name this cmd.exe. Awesome, so we've successfully written our payload. So now we'll pop back into our session, look at kind of where we are. I believe we're in system32 right now, so we'll go up a directory. And we're going to just upload our cmd.exe. Awesome, so now our payload is ready and we have our listener already on standby, so we're ready to get some shells back. Remember, 2 is 1 and 1 is none. So I'm going to spawn 2 more so we have 3 shells to work with. And I could use the execute function, but I had some problems with that before. So I'm going to drop into a shell and simply execute the current directory's cmd.exe. There, we got 1 session open, and we'll do it again. 2 sessions open. Awesome. So we'll exit out of that. Background, and take a look at the sessions we have. Awesome. We have 3 system sessions now, all ready to go. So we have some stuff to work with. Next, we're basically going to take a look at Metasploit's post-exploitation modules and pick one of those to perform the rest of our task. So to do that, I'm actually going to search for the word persistence. And that's going to bring up a lot of persistence modules. And if we take a look at the Windows ones, we have this Windows local persistence, registry persistence, persistent service, persistent image exec options. And we're going to take a look at the local persistence. Now, registry persistence and local persistence are actually fairly similar in that they both modify the registry to actually execute something on startup. The way they do it's a little bit different, but we're just going to pick one. The persistent service is actually a really neat one because it sets up an actual Windows service that will execute on a given interval. So I really like to use this one too, but sometimes you may have difficulties configuring it with 32-bit versus 64-bit payloads. So make sure you test out everything in your own environments and try to emulate your targets as close as possible to avoid issues like that when using canned out of the box, scripts and exploits and stuff. All right, cool. So we're going to use 11, which is the Windows local persistence, just a basic module. So we have a couple different options here. We can specify the exe name, the path name where this will go, the actual registry name, the session name. I'm only going to specify a few things just to kind of keep this simple. So we'll specify the exe name as svc host.exe. And we'll specify the path as c:\Windows. Actually, may want to do c:\Windows. There we go. So we escaped. Cool. So this is going to store this svc host.exe in the Windows directory, which shouldn't be a problem. And then we have the option to do a registry name. By default, it's a random value. We can select the session, which we will do. We'll set the session to session 1. And then we'll also set the startup value. So we can select this to start up as a user or as system. Since we have system privileges, we want to keep system privileges. So we'll set this startup as system. Now there is a benefit to kind of hiding and scattering different persistence mechanisms as different privileges. For example, since we know this system hasn't been patched and it's on Windows 7, there's a lot of privilege escalation exploits that we could use. We don't even have to rely on misconfigurations. So we could do a user, log in as a user, escalate our privileges, and be back to where we want. So it's worth considering setting up more than one persistence avenue, even as like a lower privileged user, just so you can get back to the system. All right, if we take another look at our options, see if we've got everything set here. I think we've got everything that I want to set. We can, of course, change the VBS name and other stuff, and it's recommended that you do these things. One, so you're keeping track of exactly what you put and where, the exact values and all that kind of stuff. And two, because you want to kind of blend in as much as you can. You don't want this to tip off somebody. We're in an environment where they don't really have any alerting or logging past like maybe local event logs or something like that, which we could clear out. And so the only thing that they have is looking at, timestamps or things that look kind of out of place on the system. And if they're not familiar with their system, there are still things in that we can spoof. So we could, time stomp over different timestamps, and we could put things in really convincing places that make it hard to tell. So unless they truly know their system and know something shouldn't be there, we can live on this for a long time. So take a look at our options. It looks like we've got everything set up. The only thing that we want to change is this payload. So we'll set the payload to be what we've always had it as Windows 64-bit interpreter reverse TCP. Take a look at the options again. And we'll set the lhost to be that udemy-c2.injection.sh. Set the L port to be port 80 where we're listening. And now take one last look at our options, and it looks like we're good to go. So now we'll run this. Awesome. So it looks like we've got the Visual Basic script is written to the Windows. All right, so awesome. It looks like we've got the VBS script written to the Windows directory. We've got a randomly named registry key, and everything else should kind of be put where it goes. It's nice they also give us this cleanup script, so we can actually run this to clean things up afterwards. This is important because as a red teamer, you kind of want to log everything as you go. You want to know exactly what you did, where you put things, and keep a record of that. Because after the engagement, you may have to help the blue team clean up. In fact, in most cases, you should be helping the blue team clean up because they may not find everything. You did your job and did it well, and unfortunately, if they weren't able to keep you out, or even if they did, any artifacts you drop, they may not find everything, and these are not your systems. So to be a good professional, you got to make sure you clean up. It's nice that some of these interpreter modules give you some cleanup scripts to assist in that process. So now it's safe to say we're pretty well grounded and not too terribly obvious that we're on the system to the common eye. Now we can give our operator the thumbs up to move on to their next objective, and we can keep playing around on the system, looting things, establishing even further persistence, playing different tricks that we need to play to maintain our access and stay in. And once we feel comfortable, we can actually start taking actions on the objective. My next objective is to simply try and gather credentials. For the sake of the scenario, we already know this host doesn't have anything we need on it. But gathering credentials is not only going to help cement us further on the system with our persistence, it's also going to help us move laterally if these credentials are used anywhere else, or if it's an Active Directory environment and this user has access to other systems. So with those creds, we can now easily hop around. So let's do that. We'll hop back into session 1. And we'll load in the Kiwi module. I believe Kiwi is on Windows 7. Yep, should work good. You have Kiwi and Mimikatz. They're both Mimikatz, but one is the version that's built for older systems, and one's built for newer. So Kiwi's for the newer systems usually. So we can look at help to see what our options are, and we can just run creds all in our case. We don't have anything really to lose here. Nothing special we need to do. We don't need to do any golden tickets or anything. We just creds all and see what kind of credentials we get. Look at that, clear text passwords right in memory, just like we would expect from a good old Windows 7 system. So now we can take this credential, mark it down somewhere, and go use it. So that's all for this section. Please take a look at the assignment of setting up the simple C2 server for yourself and give this stuff a try. If you want to walk through the full scenario that we've done here and don't have access to an adequate lab, I suggest that you take a look at Rapid7's Metasploitable 3 Vulnerable VM. You can use that to emulate the scenario locally. I'll have it linked to the materials for this section. See y'all in the next lesson.